everyone. Welcome back to our YouTube channel, Becoming a ROS Developer. Today we have one of our students, Vladimir, who has completed the course ROS Basics in 5 days, ROS 2 Basics in 5 days. And at the end of this course, you can do a project and present it on a real robot. So that is what we're going to be seeing here today. So hello, Vladimir, how are you?
Hello, I'm good, thank you. How are you?
I'm great. Thanks for asking. So yeah, whenever you want, you can start sharing your screen and show us what you've done with your project.
Okay, so I will start share now. I will start with the robot and then I will go for the presentation, okay?
Oh, great, great, great. Hello? Oh, hello?
Yeah,
Hello? Hi.
hello.
Hi, hi.
Yeah, yeah,
Seems like we lost you or something.
yes. I had the issue here with the connection, I think, or the sharing screen. Okay. Um,
But there's like two people, two of you in the call. So,
oh,
oh, there
now
we
it's
go.
okay.
There we go. That's better.
Okay,
All right. Cool. So
okay.
we were going to try and see your screen.
Yes. Okay, I hope is it working now?
Yes, now I can see your screen.
Okay, that's great. Okay, I think you went out of the website, so I will need to. Okay, so now we're loading the workspace
Mm-hmm.
and we're going to connect to the real robot. And then I'm gonna run the application and I will talk about it in the presentation. So just small brief while we're loading, anyway, we need to wait. We're going to launch the main launch file, which will launch 3 launch files. Each launch file will run then the node, and the robot will do the operation as we will see in a second. Okay, we seen the robot, right?
Yeah, we can see the robot now.
Okay. So 1 second, just make sure all good. I will build it for a second and source it. And launch the main.
Okay.
Okay. Okay, so when the launch file starting to run,
Mm-hmm.
uh, it should start with the main file, which is called wolf follower, which let's see, wait, because I have the presentation, then I will not have what to speak later.
So, all right, we see the robot moving
Yeah,
around,
so in the
which is the
moving,
objective.
I'm not super happy with the movement because I think it's a bit, is always fixing the movement, and I
Uh-huh.
think it should be doing better. Okay, I should work on that part, but I couldn't finish it on time. But it's keeping the distance between 2.8 and 0.37 or something like that.
Uh-huh.
So it's always around 0.3 from the wall. And it should, we started far away there. So it should stop there, basically, after 5.5 meters of traveling.
Okay.
So we saw now that he did a fix and then he fixed again. It's not as smooth as it could be, but for now, that the result I could do.
So
So we should,
we're approaching, right?
yes, we're approaching, and we should stop.
Maybe you didn't catch that. Oh,
It will be
sorry.
weird because
Are you there?
yeah, I'm here.
Oh, okay. Sorry, I had a weird screen issue. What
Okay,
were you
okay.
saying something? I'm sorry.
Yeah. I said that I was waiting for him to stop, but he
Uh-huh.
didn't. I don't remember that I changed the file, but before he was doing the stops.
I'm sorry, it's based on distance traveled?
Yeah.
Oh, that's weird.
Um, yeah, that's weird. Maybe I check it. No,
And the
I think.
odometry is working, right? Otherwise your
Well, I tested
file
it.
wouldn't work.
I tested it before yesterday, and yeah, it was okay.
Can we just double check and open quickly another terminal and echo the odometry? Oh no, it's
Sorry.
without an S
Topic.
and then autumn. And can you make that big? Oh yeah, it's working.
Maybe I touched it 1 second before by mistake. I'm not sure.
Can you make it big so
Yeah.
we can look at the numbers? Position. Yeah, it looks like it's giving out a value. Was it changing 1-to-1 because it's moving right now? Yeah, that's twist. All right. Well.
Yeah. Okay.
Do you have the odometry recorder right now working?
Yes.
Okay,
I think maybe I just deleted this path by mistake. Because my test before yesterday was okay.
All right. Well,
And I
maybe
guess
we'll catch it. So
yes,
in the
maybe
presentation.
we can do another test.
Mm-hmm.
Okay. So maybe if we will have the time, I can after the presentation check it. It's 5 minutes. Oh, maybe okay. We have some few minutes, right?
Like 6 and
Okay.
well, less from the presentation.
Yes.
So I still haven't confirmed if the odometry moved. Well, when I asked you to check the odometry, I wanted to see changes in the values. So I don't know if it's working.
Okay.
So if you echo it, don't Control C it for a while. We should see it move. There we go. Yeah, it is moving. So once it starts moving forward, yes, the X is now decreasing, which means it's working. Okay, cool.
We give it a try until
Yeah,
the
we can
end of
just
the
leave
round.
it running in the background, and so we don't waste time. You can just go ahead and tell us how you've solved. These.
Okay, so I open the presentations, okay?
Yes, great.
Okay. So this project was a Python basic ROS 2. We use the Turtlebot 3. And so this project, we had the Turtlebot that followed the wall, and he had a odometry tracking for tracking the robot location and distance. Okay, the odometry was the action server. The wall finder to find the nearest wall was a service server. And the wall follower, which is the main file, was topic, publisher, and subscribers, which had, of course, the action client and action service, of course. And also the other files, they are also have subscribers, of course. And we had the main launch file that launched all the program. This robot uses the leader laser. The leader laser works by shooting a laser point and get the reflection and measured time of flight of the beam, and it's moving. It's moving some distance, which is fixed, and we have indexes from 0 to 719. So if there is no obstacles, there is infinity. Then there is an obstacle, like in the image, we have the distance from the obstacle, and this thing is actually moving on the robot, so it's calculating by the movement. Okay. We have the main class. We subscribe to the scan topic, which is the laser data in a stream data that flows all the time. And we're publishing to the command velocity to move in the robot. The service, as I said, we have the find wall service that we're calling for a logic to find in a wall. And we have an action to odometry to call the odometry recording and getting feedback all the time, okay? And it's working with multi-threaded to be able to run multiple callback at the same time and not blocking the application, okay? And the odometry is basically for robot navigation, to know the position, the orientation. The odometry class that we created subscribing to the odom topic, which provide us a lot of data about the wheels, the sensors. We can also imply with real cameras and gets other data. The accuracy can be not always accurate with time because it's not always super precise.
Right.
Okay. And okay, so it stopped.
It stopped. Nice.
It did stop, yeah.
Can we see the output of terminal 729?
Yes.
Uh,
Okay, yeah, well, yes, I need to stop it, yes, I know. It's still running the node.
yes.
Yeah. This is not perfect. I know I need to fix some things, but
Okay. So let's go right into it. Do you, with my questions, are you okay with that? Are you done with the presentation?
yes.
Awesome. So that right here is another situation, right? Because the node was running.
Yeah.
The node was running. We can't connect anymore. That's fine. The node was running, but it wasn't moving.
Yeah,
right? The
true.
robot wasn't moving.
Yeah, the node was still running, and the robot actually stopped. It's it's unfinished part actually that the node should stop. It's
Right, but my question is, why did it stop?
well, you're asking why did it stop?
Yeah,
Because we send a message to the command velocity to
based on that
stop.
distance, no?
Yeah, based on the distance when we calculated from the odomy,
I see.
after the distance was what we
So then it did complete correctly. Right? I'm not understanding. So if you detected that distance and sent a 0 command velocity, which we saw because it wasn't moving, that
yeah.
doesn't mean the node will die. So that's why we probably saw it
Yeah,
running still.
yeah, exactly. The node didn't die because it's still running, but we did send the linear.x to 0 to the command velocity, and the robot stopped. I don't know why it didn't stop in the first time.
Can we see where you sent that
Yeah,
precisely in here?
yes. So, are you seeing my screen?
Yes, I am.
Okay. So, first of all, we have a value of 4.0.
Yeah,
Okay.
the target
And
distance.
yes, and
There it is.
we have that if checked.
Oh,
What just happened?
I don't know.
I think it's the server. Okay.
There we go.
Okay. We have a if check that um, that
Yeah.
the distance is correct, and it sends stop into the robot, which puts the a message to linear uh, velocity and angular to 0.
I see. So
To
that
the
stop robot, that's the only place where you're using it in line 117. So if you double click stop robot, we can actually see how many times you've used it. Yeah, that's it. Okay, so that's good. The one thing I didn't see though is the list. So in the exercise 3 for the action server, we ask for the list of positions that the robot traveled among uh, throughout that loop. Is that something that was spat out in the terminal and we didn't see it because the node was still running, or what happened there?
no, I might didn't go to it in the best way yet. Or maybe I might missed it.
Oh,
Um,
okay. So
I
there's no list of. Can we look at your action server basically?
yeah, no, the list, why is it okay? The list
You can close it and open
exists
it
because
again.
we do collecting the data, but I didn't use it to see the starting position and try to finish in the same position with the odometry data.
Okay.
I just use the distance. 1 second.
Can you close it and open it again?
Yes.
You have to click it twice. All right.
Yeah.
So that autumn recorder, what is it?
Yeah. Yeah, we have the other recorder, and we do collecting all the points.
Yeah. You're turning it into a distance, right?
Yes,
You're
yes.
squaring it somewhere. I think in the
Ah,
callback, you're using that Euclidean.
yeah, we stopping the robot basically.
No, I mean to calculate that target, that distance traveled. How are you doing that? Yes.
Yes. So there is the function with the square root and the two positions. And then we're doing a stop message to twist, and we put in the linear x and angular z to 0, and the robot stop. And
So
it's
you're then sending the stop robot in two places, right?
well, Basically, but we see, yes, it's true
Okay.
because we have the stop robot here and we also have it in the check in the wall follower. You're right.
Right. Okay. Okay, I understand. So that's one thing to start debugging is like you don't know where it's coming from, right?
Yes,
So you
yes, you're
want
right.
to just put it in one.
Mm-hmm.
And all right. So I guess that answers why maybe it stopped one time and one time it didn't, you know, because
Yeah.
maybe they stepped on each other, this autumn recorder and your wall following. So
Mm-hmm.
that
Yeah.
might be a reason.
Mm.
And is there any feedback you're providing while the robot is moving in this action server?
Yeah.
So,
Well,
which is the distance traveled, right, or something?
yeah,
Is
it's
there
yeah,
some?
yeah, it's the distance travels
Can
because we can see it here. Yeah, we can see it here.
okay, okay. The feedback callback. All right. Huh. You should also place that feedback callback inside the like. You should do everything regarding to the action server in the action server.
Ah,
Because I see this is in the wall following. It works, but I mean, it might get confusing.
yeah. I'm sure I need to fix many things.
Yeah.
It was not so easy, the project.
No, and it's a good job, man. So congratulations for achieving
Thank
what you did. The
thank
one
you.
thing that it is missing though is this last requirement
Mm,
of providing a list of all the
mm.
points, basically, which you did. I saw it. You're basically calculating the distance traveled based on the points that the robot is going through. So we just wanted that extra step to provide that list. But other than that, really nice job, Vladimir. It's a really nice project, and yeah, so congratulations.
Thank you very much.
All right, is that that's it for me? So again, really nice job, and I hope you learned something.
I learned a lot and I enjoyed it very much. I think that's great.
All right, awesome. Well, great. Then we can just maybe move back to my screen over here. And yes, guys. So this is what you can do here once you take our courses in order to get a certificate and to present your knowledge basically in this project we have prepared that you then apply on a real robot. So I invite everyone to do what Vladimir did here and show us what you've done with your project. And thank you one more time, Vladimir. I hope to see you for for your next presentation.
Thank you very much. For sure, I will be there.
All right, guys. That's it for us. We'll see you guys next time in our next video. Bye-bye.